Physics Part 164. An alternating current in a wire can be thought of as electrons moving backwards or forwards and passing on their energy by collision. The power generated in a resistance R is given by the usual formula: P is equal to I square into R. But here the current I must be written as I capital is equal to I0 sine watt. Thus P is equal to I0 square R sine square watt. Because I0 square and sine square watt are always positive, we see that the power P is also positive. The expression we have just derived from P gives the power at an instant, which is much more useful is the average of mean power. This is quantity which must be used in assessing the power generated in the resistor. Because I0 and R are the constant, the average value of the P will depend on average value of sine square watt, which is 1/2. So the average power delivered to the resistor is P is equal to 1/2 I0 square into R is equal to half V0 square divided by R. This is half the maximum power. We could use the average value of the square of the current or the voltage in these relations. The square root I square is called the root mean square or RMS, the value of the current, or similarly the voltage for the same. The numerical relations are also described in mathematical form. The RMS values are useful because they represent effective values of current and voltage in AC current. A direct current with value of I equal to the RMS current IRMS of an AC circuit is produced exactly the same heating effect in a resistor as there in the earlier one. In specifying a domestic supply voltage, it is the RMS value that is quoted, not the peak value. The RMS value of the current or the voltage is the value of the direct current or voltage that would produce heat at the same rate in a resistor. We've got an example for you. A 1.5 kilowatt heater is connected to the domestic supply, which is quoted as 240 voltage. Calculate the peak current in the heater and its resistance. The RMS version of the power, current, voltage equation is IRMS is equal to P into V, P divided by V RMS. This gives IRMS, the peak current, 8.8 ampere. The resistance R is 240 divided by 6.3, 38 omega. Now it's your turn. A heater of resistance 40 omega is connected to the domestic supply of 240 volt. A. Calculate the average power in the resistor. B. What are the maximum and minimum values of the instantaneous power in the resistor? Rectifiers. It is sometimes necessary to convert an alternating current into a direct current. This is because the most electronic devices require direct current, whereas the domestic supply is alternating. The conversion can be done by a process known as rectification. Suppose a single diode is connected in the AC circuit. We know that the diode allows current to flow in one direction only. This means that the output voltage across the resistor will consist only of the positive half cycles of the input voltage as shown in the figure. The diode has rejected the negative part of the input, producing producing a unidirectional current which fluctuates considerably.